This screencast accompanies my brief lecture describing the superposition of wave pulses. The superposition of wave pulses is your first introduction to what is called interference. There are two basic types of interference. There's what's called constructive interference, and then secondly, destructive interference. Normally, I demonstrate both of these to you by using some springs. I have you do this in an activity, but in place of that activity, this screencast will have to suffice. Okay, so first of all, what I'm going to create here are two transverse wave pulses that have the same orientation. This pulse up here is going to be propagating to the right. This pulse right here is going to be propagating to the left. And then the combination of the two wave pulses is going to be depicted here in this portion of the animation. Okay, now ultimately, mathematically, all that's really being added together here are two functions. One function that describes this pulse here propagating to the right, and a second function here that describes this pulse propagating to the left. Okay, when you see the two pulses superimposed for a brief moment, the amplitude is going to be extremely large. That's why this is referred to as constructive interference. But keep in mind that there's nothing really moving down the length of spring. All that you're really seeing here is the addition of force vectors as the energy propagates through the medium. Okay, let me go ahead and set this into motion like so. And then watch what happens here as the pulses then combine or superimpose, like so. But then the pulses just continue on their way. They don't bounce off of each other or anything like that. We don't use that terminology because that implies that they're objects or something like that, like balls or something, but they're not. Once again, all that you're seeing here is the addition of force vectors as the energy propagates through the medium. Okay, so that's constructive interference. Here's now destructive interference. Okay, with destructive interference, you have two pulses that have opposite orientations. This one here is going to be propagating to the right. This one here is going to be propagating to the left. This particular pulse here that propagates to the left is pi radians, or 180 degrees out of a phase with respect to this pulse here. Once again, mathematically, all that's really happening here are two functions are being added together to end up then with what we see on the spring. Once again, keep in mind that what's really propagating here is just the energy, and all that you're seeing are the addition of force vectors. Now, if the two amplitudes of the two individual pulses here and here are exactly the same, but they do have the opposite orientations, then at just the right moment down here where the pulses are completely overlapping each other, they will cancel each other out. That's why this is referred to as destructive interference. Okay, let's see if I can time this just right and pause the spring, for example, right at the moment that the pulses overlap each other. Like so. Ah, very good. I was able to get that on the first try. And so then therefore, if you took took a picture rather of the spring, for example, at just the right moment, you would see that the spring is completely flat, but the spring is still moving. The energy has not been destroyed here. The energy just keeps propagating on its way. Like so, and then the pulses just continue. So that's a nice example of destructive interference. The two major types of interference are constructive and destructive.